We're starting parabolas today, and the issue is that we've done parabolas. Do you remember parabolas in what's called transformation form, where the vertex was at h comma k? Everybody remember this form? Okay. What did the a do in this form? Yeah, a was the stretch, and or it may have flipped, reflected it up or down. Do you remember that? Okay. Today we're going to start talking about parabolas that go sideways, and we're going to introduce some new vocabulary about parts of a parabola. All right, so primarily these three learning targets today. You can graph a parabola, complete the square, and write the equation. Thank you. Haley, this is for you. I don't think I showed you guys this picture yesterday, did I? Of what conics are? I showed the other classes, but conics are when you cut cones, literally. So a circle is when you cut through the cone parallel to the base, you get a circle. If you cut it a slant, you get an ellipse. If you cut parallel to one of these slants, like this, you get a parabola, okay? And a hyperbola has two branches, and we'll talk about that later on another day. All right. You were introduced to this crazy one yesterday. Do you remember we had to do some completing the square when it came in this form? Or remember I made you do that one where we multiplied it all out and it was a hot mess? Okay. We're never going to do any that have this xy term in the middle. That would make our hyperbolas or parabolas or ellipses be at a slant. Like, we're going to either do parabolas that open up, down, left, or right. If you had a parabola that opened like this, so the axis of symmetry went this way, it would have this bxy term, and we're not going to go that far. The geometry definition for a parabola, first of all, a locus of points is a set of all points that fulfill a geometry property. Yesterday, the locus of points that made a circle was all points the same distance from the center. Okay? A parabola is the locus of points in a plane that are the equidistant from a fixed point called the focus and a specific line called the directrix. This is the new terms today. If you had Honors Algebra 2, you've seen those words. If you had regular Algebra 2, you may have never heard of a focus and directrix. Okay? I want to talk real quick about what this means. You're going to have some point called the focus and a line called a directrix. Okay, there's two important things right there. Focus is a point and directrix is a line. The locus of points is all the points the same distance away from F as it is from this line. So obviously I can put a point right there and it's the same distance from both. Does that seem okay? But if I wanted to have a point over here that was this far, okay, and it was the same distance away from the line, if you measure from a point to a line, you have to do a right angle, right? I want to know how far this point is away from this line. I just drop down my tape measure and measure it. If those were equal, okay, then this point here would be on the parabola. So if I were to find another place where those were equal, that distance was equal to this distance, sorry. Okay, that point would be on the parabola. So all the points where the distance from here to here equals the distance from here to here, and mine is not very good, all of those points would form a parabola. Okay? So let me see if I can come up with a reason you'd need to know that. Maybe you're going to put, this is a river down here, okay? And you want to pump water. You need a pump station that's going to pump the water, and it can go this far, and then it needs to fill up and pump, and it can go the same distance. It'll pump the water the same distance to some factory. And maybe you couldn't build it right here, which would be obvious to pump it, because there's a big icky marsh in the middle here you can't build on or something, okay? So if you want the station to be the same distance from the river as it is to the factory for whatever reason. Okay. It also has to do with reflection and refraction. There's can build a parabolic telescope mirror. Was Christian, were you talking about needing to know the focus point? What were you building? A solar heater? So it's when the sun shines, it's going to reflect from that focal point is where you need to catch the, yeah. I can look up some better applications, but there is an application for that. All right. What you need to know now, when you have this focus and this directrix, all kinds of properties, okay? Please be paying attention. This is a really important concept. The vertex right here is going to be equal distance between those two. Does that make sense? This distance is called P. The distance from the vertex to the directrix and the vertex to the focus is called P. All right? Now, things you're going to notice, the parabola always opens away from the directrix. So if the directrix is a vertical line going this way, the parabola and the focus was over here, the parabola would open this way. Making sense? It always opens away from the line, the directrix. Okay, opens away. What does it open in terms of the focus then? Yeah, the focus is always inside the concavity or the parabola. All right, so in this lesson, we're going to talk about parabolas opening up, down, okay, and to the right or the left. Then eventually in calculus, you're going to use the word concavity. Remember that word? This one is concave up, right? Because it opens up. We're just going to say it opens up. But all right, let me go back and talk about the equations here. Do you remember what this is? An axis of symmetry? Goes right down the middle of the parabola. So for this parabola, it would have been here. For this parabola, it would have been here. For this parabola, it would have been here. What do you notice? What's the relationship between the axis of symmetry and the directrix? Yeah, they're going to make a right angle here and be perpendicular. Okay? So if one is a x equals 6, vertical line through 6, this is going to be a y equals line through the vertex and the directrix. I'm sorry, the focus. Okay? The equation we learned, let me go to extra slide real quick. This is the equation we talked about at the beginning of the lesson today. Okay? They're going to rearrange things. We're going to subtract the k over to the other side. Pretty good? Now, how does that compare to what's on your yellow sheets? Can you find parabolas on your yellow sheets? The very first one on the top left says this is isolated right here, this x minus h squared. Does everybody see it? Okay, so if I divide the a over here, actually what we're going to do is we're going to replace a. We're going to put 4p here instead of a. If we were to replace, this would have been 1 over a if we divided it over here. So 1 over a equals 4p, or 1 over 4p equals a. That's why, do you see at the bottom underneath the box, I hand wrote this in for you? See that underneath there? The stretch A is actually 1 over 4p. Okay? What is p again? You have to know what p is by concept. The p is the distance from what? The vertex to the focus or the vertex to the directrix. Okay? So this is a distance. The 4, developing the 4 is kind of complicated. Just know that there's a 4 there. I'm going to let you use this reference sheet anyway, okay? The other thing I want you to be real clear on, this is 1 over 4p. It's not 1/4 p. Do you understand that the p is in the denominator? Okay. So it's 1 over 4p. All right. So we have all different kinds of forms now. They're going to write it like this. Now, remember when we had an x squared, the parabola opened up or down? Everybody good? Depending what the a value was. So whenever you have in the parenthesis an x that's being squared, it's going to open up or down. Today when we start doing sideways ones, if it has a y that is being squared, then it opens sideways. Okay? It opens horizontally, either left or right, when the y is in here being squared. And again, conceptually, p is the distance from the focus to the vertex or the vertex to the directrix. All right, you have this. I'm not going to take your reference sheet away from you. This will give you all of the concepts you need to know. It says the vertex is still HK. Does that seem familiar? Now, notice here, the y is squared, but the y still goes with the k. So the k goes with y, so it's still HK down here. Then the focus is going to add p, because it's going to add that distance inside to the focus from the vertex. That's where this comes from. You're adding the p value. The axis of symmetry still goes through the vertex, whichever direction. And the directrix is going to subtract because it's outside of the parabola. So it's h minus p or k minus p, depending if it's horizontal or vertical. Let's try to put this all together real quick. If I look at this equation, and it told me to graph it, this one is done for you, so just watch. I look at my sheet and I write down, well, this matches up to this form. Does everybody see what I did? I just copied which one it matched up to underneath it. So now what can you tell me? The h is 3. The k is, be careful, -4. And if 12 is equal to 4p, then p is... Now, you should be able to do everything that it says on the reference sheet, but let me go through that conceptually with you. The vertex is now 3, -4. So I go over 3, down 4, and there's my vertex. The squared quantity was the x, so it opens either up or down. The p value was positive, so it opens up. Okay. The p value of 3 tells me I go 3 units up to find the focus, which is then 3, -1. 3 units down from this -4 would be -7. It's a horizontal line, so it's y equals. Now, if I didn't do that conceptually, I could go to the sheet and it says h, k plus p would give me the focus. H is 3. K is -4, P is 3, so I get 3, -1. Is that what I did conceptually right here? And then it says, on the sheet, it says the directrix is y equals k minus p. If I did y equals -4 minus 3, I'd get -7. So You can do this using your brain and the concept of what P is, or you can use the little formulas on here. It's just like a recipe card. All right, so let's try this one. Oh, big difference though in this one. What's happening this time? If I copy from the sheet, this is y minus k squared equals 4p x minus h. So what can you tell me? H is 3, and over here, yes, minus k, so this would be minus the negative 1. And in here, 4p equals 8 means p is 2. Which direction is this parabola opening? What was squared, the x or the y? The y was squared. Whenever y is squared, it opens sideways. So it either opens left or right. How do I decide which? The p is positive 2, okay? The 4p is a positive quantity, so it's going to open to the right. Yes. That information, by the way, is right here. Does everybody see? P is greater than 0. P is less than 0 down. P is greater than 0 to the right. P is less than 0 to the left. Now, P conceptually is a distance, so can a distance really be negative? Okay. That distance would be the absolute value of P. I should clarify. But you use P in all those formulas. All right, so let's finish this. I'm not going to use my reference sheet this time. Where is the vertex? Always H, K. So I have 3, negative 1. There's my vertex. Now, what did we decide P was? But we said this one is opening to the right. So 2 units back this way and 2 units in this way should be something. Which one is the focus? Yes, this is the focus because my parabola is going to the right. So the focus is inside here. Can you tell me what the ordered pair would be? Yeah, 5, negative 1. Okay. And back to this way was the directrix. Remember which is a line? It's a vertical line. Anybody know the equation of that line? Yes. It crosses the x-axis at 1. It is x equals 1. All right. So we just found everything they asked for except the axis of symmetry. What would the axis of symmetry's equation be right here through the middle this way? Y equals negative 1. Yep, crosses the y down at negative 1. Okay, so the actual parabola, guys, does not touch the focus. It goes through the vertex, and this is the hard part. If we want to be accurate with graphing that, we really need another point. This is the hardest thing for students, because I can't graph this one on my calculator. It's going sideways, right? So I need to figure out another point. If I go 1 unit away from my vertex, what's 1 x unit over here from the vertex? 1, 2, 3, 4. Pretty good. If I put a 4 in here, help me think about this. 4 minus 3 is 1. 1 times 8 would be 8. I'd have y plus 1. Whoa! I don't know how I did that, but it was pretty cool. Didn't want to do that, though. Okay, over here I have y plus 1, quantity squared equals, what did we decide that was, 8? Okay, that's not looking nice. I'd have to square root that and then subtract 1. It's going to be an ugly decimal. Well, it's easier to just give you a decimal answer than it is to try to figure out how to make it come out nice. Somebody do square root of 8 minus 1. 1 point something. 1.8, so almost 2. So if we went over to 4, you would go up about 1.8, and if you went this way, you'd go down about 1.8 from the... So I didn't do too bad at making the parabola accurate. That's the hardest part, is trying to figure out how to make the parabola halfway accurate. And I'll continue to talk about how to do that. But for now, not as worried about that. It's just that you know which way it opens and how to find those equations. Okay, I want to take a commercial break for a second. If you didn't get this and you looked at this sheet, where did it tell you to find the vertex? HK. And then for this kind of parabola, where did it say for the focus was? H, nope, it's opening sideways, so it's H plus P comma K. Does everybody see that from the sheet? And if we had plugged those numbers in, 3 plus 2 comma negative 1, we would have 5 negative 1. Is that where we found our focus? Okay. And it says the axis of symmetry is y equals k. K was negative 1, so we have y equals negative 1. We got that one, that one. And the directrix, it says, is x equals h minus p. H we had was 3. P was 2, so we get x equals 1, which is this. You see, you can just follow the recipe right on the sheet. All right. Which way is this one going to open? What's squared? The x. When x is squared, it's going to open up and down. If I write the formula underneath, I have x minus h squared equals 4p times y minus k. So what can you tell me? Yep, 4p equals 4, so p is 1. What's h? Yep, x minus something gave me an x plus 2, so it's x minus negative 2. K back here is positive 1. Okay, let's just use the recipe this time. Which recipes are we using? The ones on the left or the ones on the right of the sheet? Ones on the left, because it started with x minus h quantity squared. All right, so the vertex is at hk, which would be negative 2, 1. The focus, it says h comma k plus p. What would that become? H is negative 2, k is 1, p is 1. So we'd end up with a focus at negative 2, 2. The axis of symmetry, it says is x equals h. What was h? So the axis of symmetry is at x equals negative 2. And finally, it says the directrix is at y equals k minus p, which would be y equals 1 minus 1, or... Okay. So let's see what happens in terms of graphing this. Now this graphing paper is counting by 2's. So negative 2, positive 1 is right here. That's the vertex. We have the focus is at negative 2, positive 2. The directrix is y equals 0, which is the x-axis. Okay, did it turn out that our vertex is smack dab in between the focus and the directrix? Okay. The axis of symmetry is x equals negative 2. That's the one that's going right down the middle of the parabola. So which way is this opening? Up? Okay, so I'm going to go back and take out my red. It's opening up, but I really need to figure out a point. You know what? It would be better on this one to put an x value in. What x value do you want to put in? How about we go with x equals 2 right there? That seem okay? If I put a 2 in the original equation, what would it say? 2 plus 2 squared equals 4y minus 1. I just picked a random x value so I could find at least one nice ordered pair, okay? Whether it's going to be nice or not, we'll see in a minute here. What is 2 plus 2? Squared is... Everybody good so far? Divide and I get... I don't want to distribute because I just want to solve as fast as I can. I'm going to divide by the 4 and add the 1 over here. So when we put in x equals 2, we got out y equals 5. So at 2, 5, there's an ordered pair. That would also go this direction. So there's one nice spot so we can tell how wide this thing is. Could we have just typed this one in the calculator though? Because it opens up or down, right? All right. I'm going to go through this one because this one opens which way? This one opens sideways again. You know what? You guys write down everything you can. I want you to figure out what figure out everything you can. Someone want to come up and do it? Okay. Hurry up, guys. See if you can beat him. Oh, you're good. Y minus k. 180 squared equals 4p x minus h. Did everybody get p equals a half? Make sure you just write down, 2 equals 4p, divide both sides by 4 so you don't get confused, but it is 1/2. So the vertex is at hk. Yep. Counts by 2. Yep. Yes. Focus. Okay. For one that opens sideways, it says h plus p, comma k. So 6 plus a half. You can, I don't care, 6.5, 6.5. If it was an ugly fraction, you should make it exact, but this is a nice. Remember, p was a half, so it's only half a unit away, which on this graph paper is very tiny. The directrix, it says, is y equals k minus p. Okay, so it should be an equation, y equals 2.5. So if you went up to 2.5, up and up, yeah, just put it on 2. It's good enough. It's a horizontal line. Make a little line going across. All right. The axis of symmetry, can you just tell by looking at it? It's going to go right through x equals what? It's through the vertex x equals h, so it's x equals 6 would be the axis of symmetry. All right, how many of you got that far? All right, let's talk about putting in a point. Could we just put this one on the calculator? think we got a problem. Yeah. The directrix, did I give you the wrong equation? Yes, I did. Yes. This is totally wrong. The directrix was supposed to be x equals h minus p. Yep, that's going to be a great video of me telling you how to do everything wrong. Okay. I'm sorry. You go ahead. Yep. Okay, put the vertex back at 6, 3 again. And the directrix, or I'm sorry, the focus should be h plus p comma k. I gave you totally. Yes. That's where we got off track. The vertex here was at exactly 6, 3. So 6.53 is here. So it's going sideways. All right, I'll finish. Thank you. The should open to the right if we want to find a point. Which would it be easier to put in up here, guys, an X or a Y? It's going to be a Y because we don't want to have to square root anything. So somebody pick a Y value. 4. That's pretty darn close to the vertex. Yeah, let's go a little further out. Let's go 8. Okay, help me solve that. 8 minus 3 is 5 squared is 25 equals 2 times x minus 6. Okay, if I divide by 2, I get 12.5. If I add 6 over here, I have, so when we put in an 8 for y, we got an 18.5 for x. Not great, but we might be able to fit it on here. 8 plus 4 is 12, plus 4 is 16. So 18.5 would be out here somewhere. By the time it gets up to 8, wow, this is very narrow, yes? A skinny parabola. Let me explain that one more time. If I were to rewrite this equation, just watch for a second, guys. If I divided the 2 over here, it would be a 1/2. Did I lose anybody yet? If I added the 6 onto the back of that, okay? Do you remember when we were doing these up and down? A 1/2 didn't make it skinnier. It actually made it wider. Remember that? Okay, it means it went up half as fast. So why is this one skinny? Okay, moving on. I think I'm going to re-record this video. Oh, yes. It's the opposite of what it seems, yes? A 2, it had a 2 out there, so that made it skinny. Okay, but when I moved over to the other side, yep, we're just going to keep going. I'm just going to go through this one super fast just so you're a little bit less confused. What's wrong with this? If we put x minus h comma squared, what's supposed to be over here? And in here is supposed to be 4p. This is on the wrong side. How do you move it back to the other side? By negative 12 on both sides. So now we'd have negative 12 equals 4p. Whoops. Goodness. All twitipated. So I'd have p equals negative 3, and we'd go from there and graph it. I'm going to move on, or we have 5 minutes left here. All right. We're going to talk about writing an equation. This says if you want to write an equation for a parabola and you know the focus is at negative 4, 3 and the vertex is at 1, negative 3, What do you know if the vertex is at one? Okay, wait a minute. You know H and K, right? If you know where the vertex is, but you don't know which formula to use until you decide which way it's opening. So if I had to do this question and they didn't give me a picture, I would have to graph it. I'd have to think -4, -3 is down here. +1, -3 is over here. If that's the vertex and this is the focus, which way is this going? Yes? The focus has to be inside. So now that I know it's going to the left, do you know which formula to use on here? Now that you know it's going to the left, you know you should be using this guy. Okay? Now, I would do this conceptually. I would say I know H is 1 and K is -3, but I can find P too, because how far apart are these? -4 to +1, how far apart was that? If I went left 4 and down 3, and this was right 1 and down 3, what's the difference? 5. Anybody? From -4 to +1 is 5 units. So P is 5, but it's going to the left, so it's -5. Okay, those of you who are totally lost, what does it say for focus when it's going sideways? What's the formula for focus when it's going sideways? H plus P, comma K. Well, you know H was 1 and K was -3. What did they give us at the beginning for the focal point? -4, -3. So looking at this, can you write an equation right there? 1 plus P has to be -4, so P would be, you subtract 1, you get P is -5. All right, so put it all together. What's the equation look like? Y minus K become a +3 squared equals 4P. What's 4 times -5? -20. And over here we would have X minus H, which would be X minus 1. All right, let's see if we can do at least one more of those same kind. If we have a -1, +5, it would be up here somewhere. The vertex is at +2, +5. So if that's the vertex and this is the focus, be careful. Which way is this opening? Left, yes, because it's going through the vertex with the focus inside. So what's the general equation? When it opens left, this, yes? All right, what do we know? H is, this is H and K, isn't it? So I can put those in. Y minus 5 squared equals something out here, and then this is going to be X minus 2. All right, I got to figure out what P is. The focus equation, when it opens sideways, is H plus P, comma K. Put some numbers in for me. 2 plus P, comma 5. And that focus is supposed to equal -1, 5. Well, I got the 5 right, but 2 plus P is supposed to equal -1, which makes P -3. Does a -3 go here? Be careful. The -3 goes here, so 4 times P would be -12. All right, I did a pretty crummy job and I didn't get to one with the directrix, but this is the assignment tonight and the bookwork was printed off and then in the back of the room. Get started. Please, guys, look at this tonight. I know you don't have me again until Monday, But if you don't look at this until Sunday night, you're not going to remember any of this, okay? Please look at this tonight. It's tough stuff, but it's following a recipe. You get to use a card.